Hello everyone, my name is Roman. I am a senior Android engineer at Marshmallow, and today I'd like to share my experience building an IDE plugin for Android Studio to generate code. So for today's agenda, we'll briefly look at the problem that I wanted to solve. We'll cover some foundational information about IntelliJ plugins, and then we'll look at some code examples of the different steps that you will go through when generating code using a plugin. By the end of the talk, I hope to leave you with the knowledge required to implement a code generation plugin of your own. So let's start with the problem. Clean architecture is very nice. Probably most of you are familiar with it, and it's a very good way to build software that scales. But unfortunately, it has a price. For example, if you wanted to integrate with an endpoint from your backend, you're probably either sending or receiving some information, so you have some sort of data layer DTO. And if you're following clean architecture, you would then need to clone that model into the domain layer. Not only that, but you also need to implement a mapper between data and domain. Then you need to have, then you'll probably be exposing that using the repository pattern. That means you need the interface, its implementations. You also probably are using DI, so you need the DI module to connect both of those. And of course, you also need to write unit tests for all of that. Now, none of this is really difficult. We've all done it probably a lot of times. And after you do it 2-3 times and you get the hang of it, it becomes almost trivial, but it does take a lot of time, and it's also very repetitive. And as anything that's repetitive, it's prone to error. And of course, we would like to avoid that in the code that we ship. Now, about a year ago, I worked on two fairly large projects at Marshmallow, and one of the products that we have is car insurance. So the first product was Multicar, which allowed customers to get a quote in the app to get cover for a second or a third vehicle in the same policy for a nice discount. The second feature was in-app accident reports, and as you can guess, both of these features involved asking quite a lot of questions from our customers. So there were a lot of endpoints, a lot of files, and a lot of lines of code involved. The files and the lines of code that I'm showing here are just the ones that apply to clean architecture, but even that, at a few hours per endpoints, you can see how this very easily adds up, and this was something that I wanted to automate somehow and improve the workflow for ourselves. If we start thinking about the requirements for a tool that might solve this, the first thing that comes to mind is that we want the output to be editable, because sometime in the future, maybe a month, maybe a year from now, we would be probably improving our feature. We will be creating a second version of that endpoint, and that means that the code that we have generated in the domain layer needs to change. The second requirement is that the tool should be able to work with existing files, because you might already have a repository and you may want to just add a function to that. The third requirement is that we need to be able to have some safety rails, because if you're working on the mapper, it's very often that domain and data models from different endpoints are reused, and if you already have the mapping function for some class, you don't want to create that again, you want to reuse the one that's existing. But at the same time, if that model has slightly changed, you need to have a way to provide some sort of fallback so that you can handle that in a graceful way. So eventually I settled on creating a plugin for IntelliJ IDEs, but what is a plugin exactly? So a plugin runs inside of Android Studio or any IntelliJ-based IDE, and usually it would expose its features as actions. Now this gives us two really cool superpowers. The first one is that we can read the code from our project, and the second one is that we can write new code or update existing code safely. And all of this is done by leveraging the exact same mechanisms that the IDE itself uses. And in fact, quite a lot of the functionality that IntelliJ provides to us is done as bundle plugins. So for example, support for Kotlin or Java is done as a bundle plugin. Even the tools that we use to develop Android, such as the emulator, is part of a plugin as well. Things like the terminal or Git, also plugins. And with that in mind, if you would like to guess what do we need to develop a plugin, and if you thought about another plugin, you're absolutely correct. So the basic setup that you'll need is IntelliJ IDEA, and you need to have plugin devkit installed. This will give you access to plugin related tools, and it will also allow you to build your plugin so that you can install it later in your IDEs. Now, something that I found super helpful and probably I would say even required is enabling internal mode in the IDE, and this can be very easily done by going into help, adding custom properties, and adding that idea is internal flag. Now, this gives our IDE even more options and things that we can use, but we're mostly interested in two of those, which are the UI inspector and the PSI viewer. Now, the UI inspector, it can be used to find any class that implements an action or UI element in the IDE. For example, if we were to go and look at the pop-up menu in the project tool window and use Command-Control-Click on the extract module action, we would see a window that will appear. It will show the position of this action in the IDE, but it will also show us the class that implements that action. Not only that, but if you click on the class in the bottom, you will be able to see the actual code that implements that action. This is particularly useful if you already know of an action that has some sort of behavior that you want to either replicate completely or base your own plugin off of that. You can then go and see the code and use that as a starting point. The second tool that we get from internal mode is the PSI viewer, and the PSI or project structure interface is the way that the IDE sees our code as a tree of elements. So here we are exploring the PSI structure of a Kotlin file, and it has on the very top level 3 children, the package declaration, a list of imports, and a single interface declaration. If we continue zooming in, we'll see that this class has a class body, which has a function declared, and that function also has several parts. And when we select that function on the bottom right, we can see the actual PSI element of this function. We can also see all of the super types, and if we were to expand those, we would be able to see all of the APIs that the PSI element provides for us to extract information that we need or to navigate the PSI tree. Now, if we continue zooming in on that function, eventually we can get its return type, the arguments, and eventually the actual PSI type of the response that we are getting from our backend. A couple of important things that I also want to mention about the PSI viewer and PSI in general is that each programming language has its own PSI structure. So if you are working with Kotlin code, you need to interact with the PSI for Kotlin. If you want to touch Gradle files, there's another PSI structure for that. We can very easily explore once we have a PSI element, we can very easily explore and go to its parent, or we can see what children it has and get information from them. Also, the IDE does a lot of indexing, and if you remember, whenever you open a new project, there's a very annoying toolbar that says that the project is being indexed. So what is happening here is that the IDE goes through all of your project and is creating a bunch of indexes that will make its function faster later on. So for example, when we are searching for a class, the IDE can immediately provide you the answer because it doesn't have to go searching through your code every single time because it has that index already built. And the last bit is that you also have access to the Kotlin Analysis API, which is a layer that's built on top of the Kotlin PSI that gives you easier access to some information that you might need. For example, when you're trying to resolve the type to get the actual class behind the type, or if you want to handle nullability. If we speak about the anatomy of the plugin, it has mainly 3 parts. So first you have the build gradle file, which has very similar to Android declares the target that your plugin is going to be working with. It also declares the build time dependencies. In the case of a code generation plugin for Kotlin, this would be the Kotlin bundle plugin. It also has some extra information that you can display in the settings in the description of the plugin as well. The second file, plugin XML, you can think about this as the Android manifest version for plugins. It also declares runtime dependencies. So in Android, you can, for example, specify that your app requires a camera to work. And very similarly here, you can say that your plugin needs the IDE to have the Kotlin bundle plugin installed to work. And you also specify the entry points. For Android, this would typically be an activity. For a plugin, it's usually an action. And of course, you have the actual code that is going to be implementing that action. If we look at the declaration of an action, it's very similar to what you would see for Android. You have the class that is implementing that action. Here we are also providing the text that we want to display to the user. And also we're saying that we want our action to appear in the group with the certain ID project view pop-up menu. Now, the way that I was able to figure out what the ID is here is by using the UI inspector that I mentioned earlier. So remember that, it's a helpful tool. Next, once the user clicks on our action, an action performed callback will be called, and we get an event here. And from here, we can extract all sorts of useful information. But for us, we are only interested in getting the PSI directory, which is the PSI element for folders, and this will tell us the first piece of information that we need for code generation, which is where do we want to generate our code. For the second part, we need to know what we want to generate, and the easiest way that I found to do that is by just asking the user with a very simple dialog. Now, the UI for the dialog is created Java Swing, but I'll skip the details for the sake of speed. There are plenty of good resources that can help you with that. Or you can also use the UI inspector to see the implementation for any UI element in the IDE if you want to clone that behavior for yourself. And in order to make things easier for the user, we also want to add some autocomplete to the text field that will give you the list of endpoints that you have in your code base. And for that, we can leverage the indexes that the IDE has, and we will ask the IDE to give us a list of all the coding files in the project, and then we can filter by keeping only the ones that end with API. Now, this behavior for the filtering is just a convention that we have in the project. And having such conventions can help you with any sort of automation. And it doesn't necessarily have to be this one. You could also rely on the package that you're saving your API files. You could also go further and check whether those files have, or those classes have any annotations. I guess the important thing to remember here is that conventions not only help you and your teammates, they also help with automations as you build them. Once you have that list of files that contain your functions, you can then explore the PSI tree a bit further. You can get the list of classes that are declared in each of those files, and eventually the list of functions that you have in each of those. And after some very simple formatting, we can transform those functions and show the auto-suggestion to our user. Now, after we select the function, we can proceed with the generation itself. So let's have a look at the user experience of using a plugin like this and what is the output that we will get. So here I have prepared a very simple project that more or less mimics the structure that the plugins expect from a project to work. And I have already added the plugin here. As you can see, it has a nice description. And here in the core network module, we have defined a couple of interfaces of some backend endpoint that we would be calling. We have here, for example, one that returns us some movie details. As you can see, it has some primitive types. It has things like a list of enums. It has a class that has a list of other classes. So it's not the most complex of data structure that you will be passing around, but it's not a simple one either. So if we wanted to integrate with this endpoint and work with the clean architecture part, we would go into, for example, this case, the movies feature module. We will select the package where we want our code to appear. We will do a right click, select our action. And here we will start typing. We can see we get a list of all the functions that we have here. Obviously, this is a sample project, so we only have a few, but for a real project, this will show you all the options that you have. And once we select the first function, time for the fun live demo part, we'll press OK, and hopefully after a few seconds, everything works. We get a nice dialog to acknowledge that generation has been completed successfully. And if we check the folders that we get, for example, in the domain model package, we see that we have this movie details class. And if we compare that to the original one, we will see that it's fairly similar to the data layer model, but we've done some transforming. So we've removed the suffix part from the naming because that's not something that we want in our domain layer. We've also, not only have we cloned the base class, we have also done the cloning recursively. So if I go into this other class, we can see that all the nested subclasses have been cloned. Of course, we also needed the mappers, and here they are. Let me just close this windows from the left. So as you can see, we have all the mapping logic between the data and the domain model. We have the interface for the repository. We have the implementation. As you can see, it's fairly simple in this case. It's just calling the API, and before returning the result, we're calling our mapper. But we also have tests. And if we go into the implementation, we can see that all the different test cases are covered. And if I were to run this test, they will pass. And basically, at this point, we are ready to go and start working on the business logic or the presentation layer. Now, this is, again, as I mentioned, clean architecture is not something super difficult when you're integrated with an endpoint, but it will take probably an hour, maybe 2 hours, then you have to send it to code review. But by having such a tool, we can save that time. We can generate all that logic in a few seconds. The reviewer can also save time knowing because that is code that is generated by the plugin, which has been tested thoroughly, and we can save ourselves a bunch of time to work on more interesting things. So if I go back to the presentation now, all right, let's go over the third part, and we can now look at the code generation process and what is happening behind the scenes after we have selected that function. So the sequence that the plugin works in is really no different from what you would do when you were integrating with the endpoint manually. We have our inputs, which is the folder where we want our code to appear. We have selected the function. From the function, we can check the return type, and we can decide whether we want generation or not. We can go with the mapper, and so on and so forth. So essentially, what the IDE plugin is doing is it's just formalizing the process that we've all done many, many times. Next, we'll look at a few of these steps in more details. First, we'll see at how to extract information from the API function using the Kotlin analysis API. Then we'll look at how to use the visitor pattern to create a deep clone of a class. And finally, we will see how do we actually write that class to disk and have it appear in our project. So the first, in terms of how to extract the return type, there are actually two ways that you can do this, and this is the wrong way. You can, well, not exactly the wrong way, but it's probably not the ideal solution, as you'll see. You could extract information based on the PSI structure, but the PSI is a purely syntactic representation of your code. And even though you can still extract, infer, or understand the relationship about different elements, doing so is not always straightforward, and it can be quite tricky to understand what you have to do. Luckily for us, there is a second option, which is using the Kotlin analysis API, which basically allows us to do the same that we had in the previous slide, but instead of having 10 lines of code, we can do it in just a couple. And when I started working with plugins, I really didn't know much about them, and the way that I was able to understand what are the options and what are the things that I can do was first by looking at the source code, and the second one is by using very, very heavily the PSI inspector. Now, if we inspect any element, the PSI inspector, besides showing us the PSI elements, it also has this very nice analyze block at the top, which tells us some of the APIs from the Kotlin analysis API that we have available to us. So whenever I needed to explore something, I would then find that element in the code base, use the PSI inspector on that, and try to figure out what are the functions that I need to get the information that I require. The only slight notice for this is that if you were to use the PSI inspector in Android Studio right now, this analysis block will not appear, and this is actually the reason why initially when I implemented the plugin, I ended up doing it the long, painful way by just exploring the PSI. If I had to guess, the reason is that Android Studio is usually lagging a few versions behind IntelliJ IDEA, so if you are doing any sort of PSI exploration or working with tooling related to plugins, I would say that it's probably best to do that in IntelliJ IDEA so that you get access to the latest tools that are actually available to you. Next, once we have the type, we need to decide what we are going to be doing next with that return type, and the easier way that I found to do that is by using the fully qualified name for the checks. There are a couple of option or branches that we could go here. So the first one, we can check if the return type of the function has the same fully qualified name, well, if the fully qualified name starts with the same package as our project, and if it does, we can safely assume that that is a class that's defined in our project, and then we can make the clone from that. Then we have edge cases, which fall into two different categories. The first one are the edge cases that you do want to handle, and in this case, this is a list. But just by looking at the list, you can't really decide what to do with it. You would need to go one step further and get the type of the list. And then by going through the same logic that we have here, you would be able to understand whether you need to clone that list or not. The second type of edge case here is represented as a map, and similar to a list, you could argue that you can extract the type for the value of the map, the type for the key, and make your decision there. But if you start thinking about it, when you get to the mapping, the way that you convert a map from a data to a domain layer is different than what you would do for a regular class or a list. Furthermore, if you're testing the conversion for a map or for a list or for a regular class, that's also different. So any sort of edge cases that you add early on will kind of snowball and increase the complexity further along down your generation chain. So the interesting thing about the map is that out of the hundreds of endpoints that we have in our project, only one of them was using a map. So working and spending the effort to support this was not really worth it. And instead of handling a map, I decided that it would be easier to just throw an exception. Now, the reason that I chose to be very explicit about this error is because I want to acknowledge that this is something that ideally should be handled in some other way. So the developer has to know that the output of the generated output is not entirely correct. So the easiest way to do that is to just stop generation altogether and to throw the exception. Finally, for everything else, which are the things that you do not want to convert, you can just assume that those are classes from the standard library or things like offset datetime, and those are the classes that you wouldn't be cloning, and you can just use them as is in your domain layer. After we have extracted the types, we can then proceed to make a declone for them. And for this, we'll have to traverse the class declaration, and the Kotlin plugin has a visitor class that can be handy for this. It gives us a very convenient way to recursively navigate through the structure of the PSI tree. We can also pass some data along as we explore it, and there's also some data that we can return back to the caller. So a small disclaimer, the following slide that I will go through is a very simplified version. It works only with Kotlin classes. It entirely ignores nullability. It doesn't deal with any parameters types such as lists, and it also doesn't check for duplication, but it is the smallest possible example I could think of to explain the process that still works. The actual logic to clone a data class would be around 200 to 300 lines of code, and I will share a project at the end so that you can look into more detail into that. So for the API return type, we will be starting this with the data layer class. So that is going to be our input, and the other input, that the data that we're passing, is the folder that we have selected, and the return type is going to be either the cloned class or the original class if it doesn't need cloning. And so for the visitor, the only function that we will be overriding here is the visit class one, because we'll be going through classes. So the first thing that we need to do is to check whether we need to clone that class or not. And just as before, we're using the fully qualified name. That's pretty simple. Let's say that we do need to clone this class, and we can go further. Next, we start doing some navigation through the PSI tree for that class. We can very easily get access to its primary constructor. We can get the value parameters of that constructor. And again, I didn't know this when I started. You have the PSI viewer. You can find how to do things from there. And the naming, most of the time, makes it very, very easy to understand what is going on and what are the functions that you should be using. So I do believe it's something that everyone could do and learn. So our goal here would be to go through all of the value parameters of the class, get their types, and for each of the types make the decision whether or not we want to clone them. If we do, we clone them, and at the end we have a list of parameters that will be part of the constructor of our new class that we are going through at the moment. So we can use the exact same technique, use the Kotlin analysis API to resolve the parameter type to get the actual KT class PSI element, and then we use the exact same visitor that we're in, and we just pass that visitor to our class, and we will get the clone version or the same class, regardless of that. Now we know that that's the class that we want to use in the current one, so now we can prepare a string that we will be using to write the actual constructor for the new class. Once we have everything prepared, we can use the Kotlin PSI factory to create the class from just a simple string. And there are a few things worth mentioning here. The first one is that the string that we pass to the factory function for the class, or for any factory function for PSI elements, it must be valid Kotlin code or valid Java code if you're working with Java. Otherwise, the function will throw an exception, which is in a way nice, because if you're doing something that you shouldn't, or your logic has some error, you will know about that early. The second one is that we are using fully qualified names here, and while this is strictly speaking not required, in general it makes it a lot easier to work with imports because we can get them basically for free. Last but not least, the Kotlin factory, it has a set of functions to create different PSI elements. In this case, we are creating the class, but in theory, there's nothing that would stop us from creating a class, then creating a constructor and adding it to that class, creating an element one by one. But the more granular we go, the more effort this will take. So in general, if you have the option, it's better to go on the highest level possible. In this case, it's a class. That's great. That works for us. Finally, we have just created the KT class PSI element, but it's just hanging then in memory. So we need to actually write it to a file. And before we perform the write operation, we must first get permission from the IDE to write things to the disk. And we wrap the write commands that we'll use next into this execute write command function. Another nice thing that this does is that everything that we will be doing inside of that lambda will be grouped into an action that we can then undo. So if the user chooses that this is not something that they wanted, or there was an error in the process and something went wrong, didn't generate correctly, they can just press Command Z and this would be undone. Once we have the right permission, there is a very handy library function to get or create a Kotlin file. We just need to pass the name and the data, in this case, the PSI directory or folder where we want our code to appear. And at the very end, we just need two things. We will be shortening the references, and this will cause the IDE to go over the whole file. It will find all of those fully qualified names that we have added before. It will automatically shorten them and add them as imports, so you don't have to do that yourself. And last, we will ask the code style manager to reformat our file, and it will basically do that using the same code style that you have in your project, so the output that you have matches what you would normally get if you were writing things yourself. Our domain flow is now essentially ready. From here, we would just use the original data class and the result that we got after cloning, pass it back, and then work on the mapper and the logic downstream. But obviously, for time reasons, we can't go over the whole logic today. Before we wrap things up, let's just slightly go back here. At the moment, we're using a separate write command for each file that we are creating. And while this works, this means that each file is going to be a separate action. And if you were to generate 50 files and you want to undo that, you have to press Command Z 50 times, which is definitely not something I want to do. There are a couple of solutions. The first one is we could wrap our entire code generation in an execute write command. This works, but has the problem that Kotlin Analysis API does not allow you to use it inside of a write command. There is a way to override that. but the IDE is very clear by showing you a warning in that case that this is not something that you should be doing, so I would refrain from doing that. A better solution would be to have some sort of in-memory storage, and as you go and create the files, instead of writing them to disk immediately, you just store them in that in-memory storage, and this would allow you to keep using the Kotlin analysis API and having a single undo action. I think we've had enough code slides for today, so I won't go over the implementation details, but I did make a public version of the plugin that has the in-memory logic and also the code to clone a data class recursively. So if you're either curious about the implementation or you're thinking about building a project, a plugin for yourself, I think this repository hopefully is a good place for you to start. That's it for me. I hope that you found my talk useful. I'll be available for any questions that you might have after the talk, and I will leave you with some extra links in case you're interested in exploring the topic a bit more. Thank you all for listening.